Welcome everyone to the Tekcloud Big Data Science Analytics Machine Learning and Cloud Experts training. Our offering here is our training for a Hadoop Spark training that we are offering. Some salient points. Overview of those. Now, Tekcloud has partnered with the Harvard Innovation Lab startup, based out of course, the number one Ivy League, the Harvard University, based out of Boston, Massachusetts. And Tekcloud has its offices in Philadelphia, Chicago, Austin, Texas, New York, Virginia, and Princeton, New Jersey. The experts that we have on our panel are the postdocs from Harvard, MIT, Yale, Princeton, Babson in fields such as data science, machine learning, big data, IoT, analytics, and of course, cloud. So what we is a very niche panel of experts here. And out of our offerings, we are partners with, of course, the Harvard Innovation Lab startup, and principals that have accumulated this program have worked with companies such as Amazon, Databricks, Cloud, Hortonworks, AppR implementations are also under the belt. Trainers this is something that we exclusively offer. The trainers are based out of US. Our postdocs experts with US projects, so they have hands-on expertise. We have a certificate from Harvard Innovation Lab for qualified candidates after they, of course, and this is for eligible candidates that we are in this these certificate programs. And on top of that, what we offer is flexible timing. All about with mock interviews in order to get a hands-on and a little bit feel of how the process is going to be. And on top of that, as a cherry on the cake, we have a very strong network of our direct clients that we work with our integration partners. And to help this whole cart to move, we have a very aggressive marketing and a strong live on job assistance and support program. That once you get placed, we would also be involved in success. So we are not just going to leave you hanging dry there, but we're going to make sure that you succeed with the new technology, the new knowledge that you gain from us. So after having said that, what I'm going to do is I'm going to hand it over to our trainer, our SME, the subject matter experts, to go a little more in detail to talk about what this the training is all about, have you a little bit insight of what is exactly that's in store for you. So please, for the purpose.
Thank you. Hey all, this is Narasimham. So I've been working as a big data architect for the last 6 years, and I have around 15 years of experience in IT. So today we are going to talk about what exactly the Apache Spark is all about, and what Spark does in big data landscape, and what sort of problems it solves, and what are all the use cases, what are all the verticals that it can cover in order to solve the business problems. Okay, so as my first slide says, Apache Spark is one of the computing platforms that enable big data to process in a seamless fashion. So here the Hadoop used to Hadoop solves two problems. One is the storage, other one is the processing. The storage here is we achieve the distributed storage using HDFS, and the processing is achieved using MapReduce. So MapReduce has its own challenges in terms of processing. It is the way it serializes the data, the way it processes the data. It is more of a batch processing kind of a system, and people have a lot of SLA issues in terms of processing their data sets. So that's where the Apache Spark is something that has been brought in, and the Apache Spark is like an in-memory kind of an engine where the majority of the data that gets processed in memory rather than serializing the data onto the disk. So disk I/O is always expensive. That's one of the reasons why we move or migrate from MapReduce processing to Spark engine. So Spark is exclusively developed for data processing. It doesn't solve any storage issues or any other reporting or those kind of big data needs. It does purely processing problems. So as the slide says here, is a Spark is a cluster computing platform designed to be fast and general purpose. And when people compare this one with the Hadoop MapReduce, it is 100 times faster than MapReduce in certain scenarios. So there were a lot many benchmarks have been done out of MapReduce and Spark really outruled majority of the processing engines that are out there in the big data space. And the primary objective of this Spark is to process the data in a distributed fashion. As we all know, so the MapReduce is to process the data that is stored on distributed machines. So here Spark does solve the similar problem, but yet it uses memory as one of the medium in order to solve the problems in a quicker fashion, fast and very elegant in terms of results. It does provide you monitoring, it does provide you the reporting, it does provide you all sort of needs, all debugging capabilities in order to solve in a given problem. So the majority of the areas are the people use Spark for ETL purposes, and Spark is used for data science operations like machine learning, predictive models, those kind of things. Okay, so the advantage with Spark here is it comes with the stack of technologies, like the way how Hadoop comes with ecosystem like Pig, Hive, and HBase, HDFS. These all are actually Hadoop ecosystem tools. So that means they're all developed on top of both HDFS and MapReduce. Similar way, Spark also comes with its own ecosystem stack. So they are called it as the Spark SQL, Spark streaming, machine learning, graphics, those kind of areas. If you compare this one with our traditional Hadoop systems, Spark SQL is nothing but our Hive system, and the streaming Spark streaming is Hadoop streaming. LLM is Mahout, and there is no equivalence for graphics. Graphics is some that solves purely graph theory problems like shortest path, like social networking, the logic. Those kind of use cases are primarily used in order to solve the graph problems. Okay, as the diagram represents, so Spark core is the primary core component of the Spark. That is the low-level engine as per the framework aspect that solves all your distributed needs. That solves all your distributed needs, like the processing the data in a distributed fashion, storing the data in a distributed fashion. All are taken care by your Spark core components. On top of it, you have this Spark SQL streaming, machine learning library, and graphics processing. These are actually derived out of your Spark core components. So this actually paves the way to implement Lambda architectures. So Lambda architectures is one of the biggest buzzword in big data space, where you combine both batch processing as well as the stream processing together in one technology stack. Earlier we had this Lambda architecture problem with the Hadoop system, because Hadoop doesn't really solve real-time processing, that is stream processing. There was Hadoop stream capabilities, but Hadoop streaming was not really that helpful or that fast compared to the technologies that we have been having now. So that's one of the reasons why people were not adopting Hadoop streaming as the core technology in order to solve streaming problems. Whereas Spark is meant for both stream as well as batch processing, and it does solve all the problems. So you can adopt Spark SQL or the Spark core for your batch processing, and Spark streaming for your stream processing. So that provides your Lambda architecture. Okay, the primary objective of this Spark is to process the data in a distributed fashion and with a fast and in-memory capabilities. The other advantage with Spark here is Spark is actually is a set of libraries. It's a set of libraries. They are all written in Scala. They are all written in Scala. Those who are familiar with Scala or Python languages, they can use these languages in order to consume the libraries of Spark and produce the results. And Spark has advantages of running the components in a local mode or in a distributed mode or in a standalone mode. You have variety of ways and means to solve your problems. Assume you have large volumes of data in a single machine and you wanted to process it here in a distributed way. That can be done using Spark. Okay, that's one of the capabilities of Spark that people really have been working towards replacing majority of the traditional technologies like Java components or the .NET components. Any processing that we have, even in local machine, even in a single machine, that processing can be improved using Spark technology, because Spark does the distributed processing even in a single local machine by leveraging multiple cores. That's one of the advantages that we can see out of Spark. And Spark comes with multiple shells. So as I said, Spark can be coded using Scala or Python or Java. So there are Spark and Scala comes with the interactive shells. So the data scientists use Spark shell, the Spark shell or the PySpark in order to do the data science work. The developers, majority of the time, they write programs and then they integrate in their own applications and then execute their Spark applications. So Spark solves both ETL as well as the data science needs. The Spark, how it has evolved here is the MapReduce has been published by Google, and then from there the cutting adopted this MapReduce. And then that's when he came up with the Hadoop technology, and he outsourced this one to Apache Hadoop in 2006 to 7 time frame, and then it became very popular during 2008 and 9 days. And then from there, the creator of Spark, his name is Matai. He's the one who actually presented a paper in Berkeley. He was a research student, and in 2009, based on one of the Microsoft's processing paper, he presented this one, and that's when the Spark got kicked off. Spark users, the core developers of Spark, they came out from the Berkeley, and then they started a company called Databricks. Now Databricks today offers a large variety of solutions to the end users in terms of cloud. So what they've done here is they have their own inbuilt clusters, and all you have to do is you just have to go and buy the cluster, and the processing, everything is taken care of by Spark. So they have very good benchmarks in terms of processing, and they have already outrolled majority of the process. Almost every processing tool that is out there in the industry is outrolled completely. Okay, now Apache Spark is very in a very prominent space, and you sort of demand a lot of demand in the market for Apache Spark. Okay, so advantages of Spark that we see here is, one of the advantages of the Spark here is it handles petabytes of data. But here the size of the data is not what it matters. What it matters here is what kind of processing that you are doing. Are you doing machine learning algorithms? Are you doing some ETL operations? Are you doing some kind of transformations? These are variety of things that actually that demands Spark capability in order to process the data. So it's one of the reasons why Spark is the best technology in order to process your data. So it is, as I mentioned before, Spark is significantly faster than Hadoop. Hadoop MapReduce. I don't say Hadoop. Hadoop is it's an ecosystem. The Spark is actually an extension or a replacement for MapReduce. So what MapReduce does here is, as I said, is a serialization mechanism, and it does a lot many things. But the problem with MapReduce is it's very slow, and the way it is implemented. Whereas Spark demands a lot of memory, and if you have memory and everything gets processed in memory, and it is 100 times faster than Hadoop MapReduce technology. And it is very simple and intuitive. We'll be seeing how simple it is, why it is we call it as simple, why people adopt Spark very quickly compared to MapReduce. We will see. In Hadoop, we run MapReduce, we write 100 lines of code in order to solve a word count problem. Where Spark, all you have to do is just have to write 5 lines of code. 5 lines of code to solve your word count problem. Likewise, there are many things that you can solve with Apache Spark. And one of the biggest advantage with Spark here is there are a lot of connectors, third-party tools integrated as part of open source. And the advantage with here is it's not that Spark has to be executed only on the clusters. It is not necessarily you have to have the cluster. Even in your own laptop, with the 15 minutes of back work, you should be able to happily run your Spark mission, and then you will be able to process the data in a distributed fashion, in a same local mission, in a distributed fashion. For example, here is you have a .NET component. So if you are processing, assume 1 GB of data which is stored in your local machine with your .NET component, probably it always uses only one core of one CPU, and then it processes 1 GB. That's unless you explicitly write multi-threading. Whereas if you adopt Spark, if that machine has quad core or octa core, 4 cores or 8 cores, your data will be processed in 8 cores. So it is much faster than what your .NET core or the Java code or any other programming language for that matter what it produces. Your Spark produces multi results. So if Castellon takes 10 minutes, with the Spark you should be able to do it in 1 minute, even in the same single mission. So a lot of research is happening today in today's world to see how we can leverage this Spark parallel processing capabilities in a single mission, so that they can solve their big data. They can solve their processing problems rather than big data problems. Okay, so it solves many things. That's one of the advantages that you gain with Spark, and Spark can be deployed on Elastic Computing Cloud, that is Amazon AWS, and you can deploy wherever you want, and you can build. The Spark cluster works very, very seamlessly. Biggest Spark cluster is a 1-hour job. Infrastructure, you have everything. It's just like that you can build your Spark cluster. Okay, that easy, and it can work with existing Hadoop clusters as well, because Spark works with Yarn. Yarn is anyway integral part of Hadoop, so Spark can easily be deployed onto the existing Hadoop clusters as well. That is one of the advantages. Whereas there is a technology called Apache Mesos. Mesos is exclusively built for Apache Spark in order to do the cluster management. So if you are looking for only processing, you don't really care about storage, or you don't care about any other Hadoopized kind of a technology, all you have to do here is you just have to adopt this Mesos and your Spark to deploy your cluster, and then boom, you can start processing. One of the biggest advantages, you can run Spark anywhere. There's no specific requirement that you have to deploy it only cluster. You cannot do it like this. You have to do it like this. It can be run anywhere. With 10 minutes, it can be run on your local machine. That's the beauty of Spark. Second, it handles most I/O. This is another biggest advantage that you really get it out of Spark. Spark can work with any source. Spark can work with any source. It can go to databases, it can go to the Cassandra, it can go to NoSQL, it can go to Kafka, it can go to Twitter. You name the source, you have the connector for that particular source in Apache Spark. So that's one of the advantages, and people have been leveraging this to the core in order to access, in order to get the data onto the clusters. And interoperable libraries, as I said, the Spark has the feature called the ecosystem, like the libraries, the Spark SQL operations, graph operations, machine learning. They're all part of your Spark core. You don't see the challenge that we have here is, if you are doing some kind of transformations, you have to learn Pig. If you are doing some kind of SQL, you have to learn Hive. If you are doing some kind of streaming, you have to learn Flume. Whereas in Spark, you get all in one shot. You don't have to learn multiple things. You have to learn Spark. the core, and these machine learning, the Spark SQL, the Spark streaming, Spark machine learning, graph process. These all are extension to your existing Spark. That's one of the advantages that you gain out of the Spark. So if your use cases demands any of these things, then you're more than happy to take this into the consideration. Okay. Now, as I said in my previous slide, so this is just a comparison. This is just a comparison. Spark compared to Spark is compared to usually Spark is compared to Hadoop MapReduce. The Hadoop MapReduce is as I mentioned, it is a more of a batch processing system, and whereas Spark is a real-time kind of a processing, because it demands a lot of memory, and it leverages a lot of memory in-memory capabilities in order to process it. So even while developing the code, you can see that how easy it is to develop in order to write the code. Okay, these are the lines that are needed in order to do the word count. So word count is very prominent example of the use case in big data space. People, if anyone talks about big data, the use case, they simply say that word count those on a distributed platform. So if you want to write the similar kind of job in MapReduce, that's all you have to do. So many lines you have to do in order to do. But whereas in big data on Spark, this is how it is. So these advantages, like it is fast, easier to develop, and low latency, in memory, 100x performance. These all are some of the things. In some of the scenarios, this 100x also has gone to 150x. Okay, there is Spark does a lot of inbuilt optimization. Spark does a lot of built optimization before it even executes the code. That's one advantage that you get out of this. So as I mentioned, Spark does really do good job when process large volumes of data with a more complex processing requirement. That's the catch point here. Okay, so real complex thing like iterative algorithms, predictive modeling, or your genetics requirement, those kind of things you can seamlessly you can adopt Spark as a mechanism to process your data. And this is one of the comparisons that industry does. They compare with Hadoop MR. Hadoop MR with Spark, and how it produces, what results it has produced, and fast it is something that you can see. The size of the data is 102 terabytes. They have processed with the Hadoop, and it produces the results, the sorting results, in 72 minutes. Spark, 100 terabytes. Here it is 102. Here is 100 terabytes, and it produced the result in 23 minutes. Though you see that only 3x performance, but the performance, if you look at it here, the Hadoop MR took 2,100 nodes in order to produce the result in 72 minutes, whereas Spark just took 206 nodes, or the cores, the nodes it took in order to produce the results in 23 minutes. So they look at it, 2,100 to 2,206. It is 10 times lesser, but outcome is 3 times faster. That is almost more or less 30 times faster than what you have been expected to get it out of with reference to Hadoop MapReduce. Okay, people have done some 1 petabyte thing. 1 petabyte is, just to give you a heads up, it is 1,024 terabytes. So 1 terabyte is equal to 1,024 gigabytes GB. Okay, 1,024 GB is 1 terabyte. 1,024 TB is your 1 petabyte. So 1 petabyte of data here, that is 1,000 terabytes. It is 200. It took 234 minutes. That is almost 4 hours. 4 hours. On only 190 nodes. 4 hours, 1 petabyte is on just 190 nodes is very phenomenal result. Very phenomenal result that we can say here. And if you could increase this 190 to 400 or something, you should be able to still see lot many advantages over this particular stuff. Okay, so these are some of the comparisons people talk about Hadoop MapReduce and Spark. Probably we can start looking into this once we really get into the class. Okay, the comparisons, how k-means clustering produces the result, how logistic regressions produce the result. This. Okay, that's I have as part of this demo. We will get to know more about the syllabi, what we're going to discuss as part of MapReduce, as part of Spark, and we are going to talk about Scala. We are going to talk about Python, because in order to program Spark, you need to have one of the technologies like either Spark or either Scala or Hadoop, or Java. But majority of the time, industry is using both either Scala or Python. So what we do here is we train you guys first on Scala, we train you guys on on Python, and then we take you to Spark, Apache Spark. So we will give you the base, and then we'll make you start coding using Spark, and then use all open source data set. We don't use any inbuilt data sets like employee database or some reservation database. We go to New York open data sets, and we bring the data from the New York open data sets, and then we start processing it. We also it is freely available, and once we get into the class, probably there we'll be able to see how we can access the open source open data sets, and then start processing it. You can shoot a mail or read the respective person. He'll be able to answer you all your questions. Thank you.
Chris, I really appreciate your presentation here. What we are trying to come up with is that we have classes starting every couple of weeks. A new batch is starting. So if you are interested, please feel free to visit our website, tekcloudinc.com. There's a link for contact us. You can go ahead and contact us over there, or if you want, you can give us a call at 69256-6996 to the appropriate extension, and somebody would be there to help you out with any of your curriculum needs or any questions that you might have regarding Big Data Spark courses. And of course, if you have any specific questions regarding anything that might have been talked about here,